Hello students, after electric field and electric field intensity, now we will study about electric dipole and electric dipole moment. Now electric dipole. Electric dipole is a pair of equal and opposite charge separated by a small distance is called electric dipole. Let two charges say Q1 and Q2. Since as we define here that it is equal and opposite charge, so it is say negative charge and this is say positive charge. So now it is equal and opposite charge. Magnitude of Q1 is equal to magnitude of Q2. So electric dipole is pair of equal and opposite charge separated by small distance. Say that distance is 2a. If first charge is at point A and second one is at point B, say this is the midpoint O, then this is A and this is also A, so total is say 2a. So that is the small distance or separation between the two charges. Now if this is the electric dipole, then total charge of electric dipole will be 0, because if they have same magnitude and opposite sign, so plus q in addition with minus q, with that will give us 0. Now what are the examples of the electric dipole? The polar molecules like NaCl, HCl, or you can say water molecule are the example of electric dipole. How? As you know, due to electronegativity difference, chlorine in partial negative charge and there appear partial positive charge. So this NaCl, which is a polar molecule, is like electric dipole because it has equal and opposite charge. The magnitude of positive charge at Na is equal to the magnitude of negative charge of chlorine or Cl. So this is the example of electric dipole, pair of equal and opposite charge. And what is the bond length of the polar molecule? That appear as a small separation, that is the 2a. Here in the electric dipole, that is the 2a. So that is the example of the electric dipole. So electric dipole is nothing, it is a pair of equal and opposite charge separated by small distance, say 2a. Now next is electric dipole moment. Now electric dipole moment, it is defined as product of, one is magnitude of either charge and the length of dipole, product of magnitude of either charge and length of dipole, and it is denoted by p vector. So as it is denoted by vector, so it is a vector quantity. Now according to definition, as it is defined as product of magnitude of either charge and the length of dipole, so dipole moment can be written as p vector is equal to product of either charge into length of dipole, say vector. This is the electric dipole moment. And what will be the SI unit of electric dipole moment? That for charge, here is a coulomb, and length, so it is meter. So coulomb meter is the SI, unit of electric dipole moment. Now direction of, since it is a vector quantity, so we will also see what is the direction of dipole moment. So direction of electric dipole moment is taken as from negative to positive charge. Say if this is the electric dipole minus q plus q, and this is the length of the dipole, then dipole moment, which is denoted by p vector, that has the direction from minus q to plus q. So that is about the dipole moment. Now if we see the dipole moment of water molecule. Now water molecule, say H2O. Here if we see the structure of a water molecule, that is H, and O. O has 6 valence electron, 1, 2, 3, 4, 5, 6, that appear as a lone pair, and here is a bond between the O and H. Now due to O is oxygen is more electronegatives than hydrogen, so here is a partial negative charge and here is a partial positive charge. Similarly in this side, so dipole moment is from negative to positive charge. So for one molecule OH, this is the dipole moment, and similarly on the left side also, this is the dipole moment. Now resultant of these two vectors P will be along this side. So this is the resultant dipole moment for the water molecule. So after electric dipole and dipole moment, now we find the electric field intensity or electric field due to the electric dipole. As in the previous lecture, we find the electric field due to point charge or electric field intensity due to point charge. Let it revise as we know, electric field or the electric field intensity at a point due to point charge, say Q. If this is the charge Q and we want to find the electric field intensity at a point P, which is at distance r from the charge, so electric field intensity is equal to Q over 4 pi epsilon naught, and the distance of the point from the charge, that is r and r square. So this is the electric field intensity or electric field due to a point charge, and this is from as E vector is equal to F vector over Q vector, that you know very well. If we place here a point charge, then the force experienced by this test charge due to this source charge per unit charge is the electric field intensity. And for the vector, if we want to write it as a vector quantity, so E vector is equal to Q over 4 pi epsilon naught r square. As for the positive charge, electric field is just away from the positive charge in all direction, so it will be along r direction for point P. So here is r cap. So that is the vector form of the electric field intensity due to point charge. Now using this result, we will find electric field intensity on the axis of, or electric field intensity due to electric dipole. Before that, first we see the axial and equatorial line of the electric dipole. Now this is the electric dipole, that is the pair of equal and opposite charge separated by a small distance, that is say 2a. Now the line passing from the axis of dipole is called axial line, and the line passing from the center of the dipole perpendicular to its axis called equatorial line. So the line passing from the axis of dipole is called axial line, and line passing from the center of dipole but perpendicular to the axis of the dipole is called equatorial line. So our next article is electric field intensity, that is E vector at a point on the axis of electric dipole. E vector means electric field intensity at a point on the axis of an electric dipole or on axial line. Now, for that, suppose this is a electric dipole. Let it draw here. This is the electric dipole with a pair of equal and opposite charge, minus q and plus q. Say this is the point A and this is the point B and center is O, and we want to find the electric field intensity on the axis of dipole, say at point P, which is here. So at point P, which lie on the axis of the electric dipole, we want to find the electric field intensity, say E vector. Now, as the distance or the separation between the two charge of electric dipole is say 2a, and the distance of a point from the center of dipole where we want to find the electric field intensity is say r. And using the previous result, that is the electric field intensity at a point due to a point charge, which is E is equal to q over 4 pi epsilon naught r square, we will find the electric field intensity at a point P due to this electric dipole. Now first we write about the diagram, that is consider an electric dipole with dipole moment P vector is equal to q into 2a vector and we have to find or calculate expression for electric field intensity that is E vector at a point P. Okay. Now Now E vector, or E1, is the electric field intensity at point P due to minus Q charge. So according to the relation, E vector 1 is equal to charge 4 pi epsilon naught, and the distance of the point from the charge, that is A p square, and since it is a negative charge, so electric field intensity is toward the charge for the negative charge, so along PA. Now this result is using the result that I already told you, that is electric field intensity for a point charge. For this charge, electric field intensity at point P is, if this is the point A, that is E is equal to charge over 4 pi epsilon naught, distance of the point from the charge, say that is AP square. Similarly here, charge is at point A and we want to find the electric field intensity and P. So distance of the point from the charge is A to P, that is AP square. And since it is a negative charge, you can write negative charge, or negative charge means electric field intensity toward the charge. So therefore I write here from P to A. Now what is AP here? AP you can write, AP is, see here, that is AO plus OP. AP is AO plus OP. So AO is small a, that is half of 2A. This is, if this is a 2A, then it will A plus O to P, that is R. A plus R. So AP is equal to A plus R. This gave us E1 vector is equal to Q over 4 pi epsilon naught. AP is A plus R square and it is along PA. That is, say, first point. Similarly, E vector 2, say, at a point P due to plus Q charge, which is at point B. Now E2 vector magnitude is equal to, again see, this charge Q, which is at point B, 4 pi epsilon naught, distance of the point from the charge, that is B to P, so BP square, and direction of the electric field intensity. For the negative charge it is toward the charge, therefore we write AP from P to A, and for positive charge it is away from charge, so we will write from B to P, not P to B, BP, along BP, along BP. So as here is a vector, so we have to mention direction here. So again, as we find AP, similarly here BP is the distance of point P from the charge. So now charge is at B, so we have to write here BP. So BP is equal to OP minus OB. As BP, we have to write BP, so we don't know what is the value of BP, so in term A and R we can write here from O to P we have R, and from O to B is 2a, so that is a. So r minus a, if we subtract a from r, then we will left with bp. So bp can be written as op minus ob. Here op is r and ob is a, so bp is equal to r minus a. So this gives us e2 vector is equal to q over 4 pi epsilon naught r minus a square, and it is along bp. That is our second point. So up to here we find the electric field intensity because of the charge at point A, which is negative charge, so it is toward the charge from P to A, and E2 is the electric field intensity due to positive charge, and it is from the charge to the point, so it is along BP. Now since electric field intensity E1 vector and E2 vector are in opposite direction, and magnitude of, say, this is the magnitude of E1, and in point second this is the magnitude of E2. In E1 the denominator is a plus r square, and in E2 denominator is r minus a. Here r plus a, here r minus a, so denominator in case of E2 is r minus a, and here is r plus a, so here the denominator is large, so the value of E1 in magnitude will be smaller than the magnitude of E2. So therefore I write electric field intensity E1 and E2 are in opposite direction, and magnitude of E1 is greater than, or sorry, less than, magnitude of E2 is greater than magnitude of E1, because denominator of E2 is smaller than the denominator of E1, and the remaining part is the same in both. This is the same in both, q over 4 pi epsilon naught. Similarly, q over 4 pi epsilon naught, the magnitude depend on this factor. So whose magnitude in denominator, whose denominator will be small, that will have greater magnitude. So according to that, E2 is more than the E1. Since electric field intensity E1 and E2 are in opposite direction and magnitude of E2 is greater than E1, therefore net field intensity at point P will be E vector, that is E2 minus E1. Due to opposite direction we subtract, and which has more magnitude, from that we will subtract the which has less magnitude. So E, that is net electric field intensity at point P, will be the difference of these two. So therefore E is equal to, now E2 is q over 4 pi epsilon naught. E2 is r minus a square minus E1, that is q over 4 pi epsilon naught r plus a square. Now what will be the resultant direction? That will be the direction of E2, because E2 is more in magnitude and it is near to point. E2 is the near to the point P where we want to find the electric field intensity. Say here is the point P and point P is near to the charge Q which is at point B. So effect at point P will be more of the charge which is at point B. So at point B the electric field intensity is E2 and due to the charge at point A electric field intensity at P is E1. So resultant electric field intensity will be the electric field intensity due to charge at point B minus electric field intensity due to charge at point A. We subtract because E1 and E2 are in opposite direction because electric field is toward the charge for the negative charge and away from the charge due to the positive charge. So because of that we subtract these two and according to the magnitude we have the resultant that E vector is the difference of these two. Now direction is of E2 that is along BP. Now mathematical part left here. These two terms are common, so take it out. E is equal to Q over 4 pi epsilon naught and 1 by r minus a square minus 1 over r plus a square and it is along BP. Now proceed. This will give us r minus a square and r plus a square, and on dividing this will denominator we will left with a plus r plus a square and minus r minus a square. Now as m2 power say x2 power n and y2 power m can be written as xy to power mn, mean in multiplication x2 power say n and y2 power n, this will become xy2 power n. So according to that we get E vector is equal to Q over 4 pi epsilon naught. In denominator we will left with r minus a, r plus a, and here is the square, so you can open it with simple identity, that is r square plus a square plus 2ra and this minus and r square plus a square minus 2ra, and it is again along B to P. Now next E vector is equal to Q over 4 pi epsilon naught. Now due to this minus the sign of the term inside the bracket will be changed, so r square plus a square plus 2ra, due to this minus r square minus a square and minus plus 2ra divided by, now here is r minus a r plus a, so it become r square minus a square to the whole square and it is along BP. Now these two cancel out, so E vector is equal to Q and this 2ra and 2ra, that is 4ra divided by 4 pi epsilon naught r square minus a square to the square along BP. Now, as in the first line, we define or write dipole moment, that is P vector is equal to Q into 2A vector, and for if this is the dipole with minus Q and plus Q, the dipole moment is from minus Q to plus Q and it is P vector. And moreover, our point is lie here, and electric field intensity is along BP. So the direction of electric field intensity is the same as the dipole moment. So E vector can be write in term of dipole moment. So that will be E vector. From here, let this 4 is 2 and R, and remaining part is 1 2 first Q and 2 from here, and this A, and the direction is along BP, whole divided by 4 pi epsilon naught R square minus A the square. Now this Q into 2A and along BP, that is the direction of the dipole moment. So this whole quantity Q into 2A is dipole moment, and direction is same as the dipole direction of dipole moment is from A to B or along BP, which is to the right side. So here E vector, this term will be become dipole moment, that is dipole moment Q into 2A with the direction. So it is, as it is a vector quantity, so we will left with P vector here. P vector is Q into 2A and its direction is BP. So that is the direction. So this is the electric field intensity due to the electric dipole at a point on the axis of dipole. Now here is a one special case, that is if R is greater than A, or for a short dipole, Now if R is greater than A, what is R? If I remind you that here is a minus Q plus Q and here is a point P, and this is the center of dipole AB. Now this distance O to P is R, and A to O or O to A, this total is 2A, so it is A and it is A. So R is greater than A, then R square minus A square can be written as only R square, because A is very small, so square of A can be neglected here. So E vector becomes 2R P vector over 4 pi epsilon naught. This will be become only R square 2D square. So here is R to power 4, 1 will cancel out. So E vector will be 2 P vector over 4 pi epsilon naught R cube. So this is the electric field intensity due to electric dipole at a point on the axis of dipole. Here E is in the direction of P vector, both are in same direction, that you have to know. So thanks. In the next video we will see how we can find the electric field intensity at a point on the equatorial point, or a point lie on the equatorial axis. Thank you.